Okay, we're going to talk about e, base e, and the natural log. If you look underneath on your calculator, underneath the log button, there's a natural log button, and it's ln, and the base of an ln. So if we have ln of x, the base is always the number e. Can't be anything but the number e. So please make note that you can't change this to a different base like 4 or 10 or anything like that. Where the common log is base 10, can be anything else, but you always get base e. There is a mathematical spot that this comes from. We actually talk about that in pre-calc. So if you if you get the pleasure of pre-calc, then we will talk about exactly where the number e comes from. But it is 2.71828, and it's always the base of the natural log. On the calculator, the ln is on the left-hand side. Second and the ln key will give you an e to a power. Second and the division sign will just give you the number e. So if you need those, you can find them in your calculator. We will do some exponential growth and exponential decay functions with the natural log and with the number e. Okay. And you can see down here that the ln of 4 is a log of base e. We would never write the log of base e. We always write ln, and we know that the ln always has a base of e. So it's as simple as if I have a base of e there, I'm going to just have the ln of 23 equals x. E to the x is 23, and then I could type this into my calculator if I wanted to find that. Now, if I wanted to actually solve this one, I would just type e to the fourth in my calculator, but they want us to rewrite it as a natural log. So that would look like this. E to the fourth is x. I don't know why you would ever do that, but you can if you're just rearranging stuff. So here we go again. We have this would be ln of 15 equals e because I have a base of e. Or it'd be ln 15 equals x. Geez, what's that one? ln of 15. E to the x is 15. So you can visualize, just like we did it with the log base 10 and with the other log bases. E is the base. This is an exponent, and we get to 15. Good. This one would be, well, we already did this one. ln of x equals 4. ln of x equals 4 on that one back there. Write this in exponential form. Okay, we're doing the same thing. E to the 1.2528 equals x. If you wanted the actual value, go to your calculator, second ln, and now I'll type in for the exponent 1.2528. This must be a special one. It's about 3.5. 3.5. So there you go. X is 3.5. All right. E to the x equals 25. I don't think we need to take a look at too many more of these. These are very redundant. All of the same rules apply to logs, okay? So you still have all of the same rules. So if I was to write these as a single logarithm, I would put the 3 to the fourth up there, and I'd have ln of 3 to the fourth plus ln of 6, which would be ln of 3 to the fourth times 6. I would actually have to grab my calculator and do 81 times 6 and get 486. This would be ln of 486. So we can put them together just like this is the same thing. You can put them together. All of the same rules apply for natural logs as for common logs. So we can put this up here, ln of 2 to the fourth times 3, right? Because plus means multiplication, which is 16 times 3, which is 48, ln of 48. So all the same rules apply. When you're solving now, I would do the same things that we did with common logs. Same things we did with logs we've been doing for the last week and a half. And I get 6, and I would divide by 3, and I'd get e to the 2x equals 2. And now you can either take the natural log of both sides, or you can rewrite it in ln form. I find that people actually enjoy this better. Not enjoy. Who enjoys this, right? Negative 2x ln e equals ln 2. Well, what's the ln of e? The ln of e is always equal to 1. E to the 1 is e. So now I can solve by dividing by negative 2, and I get x equals whatever ln 2 divided by negative 2 is, I get, oh, look at this fun number, negative 0.34657. 34657. There you go. Check your work, plug her back in there. It's going to work. So all the same things that we've done to this point, same idea here. I would subtract 5 from both sides and get divide by 2 on both sides. And now again, you could write in ln form, or you can take the ln of both sides. So anytime you have an e, you're just going to be dealing with natural logs. Ln of e is equal to 1. Don't forget that. That's going to come up a lot in your math career, specifically if you're going to go on at all. So now I get x equals whatever ln 5 divided by negative 2 is, and I get negative 0.8047. There you go. All right. We divide by 2. We could do the same thing here. I think we've done quite a few of those. Okay, when am I ever going to use this in my life? There is practical application for natural logs. It comes with when interest is compounded continuously. If you want to get interest as fast as you can, so monthly is better than quarterly, daily is better than monthly. You would like to get interest hourly, and then you can get it continuously, and it actually works itself out. And this is going to be A equals PERT. A equals PERT. This is the principal. That's the initial. Oh my gosh, y equals a times b to the x. Very similar. Initial. E is just a number. This is the exponent. It's the interest rate, and that is going to be time. So we can use, we can do PERT. Suppose you deposited $700. That's the principal. That's the initial investment, okay? Initial investment. So we put the 700 here. And we're getting 3%, and it needs to tell you it's compounded continuously. You got to see that in order to use the PERT equation. Otherwise, you're going to continue to use that other equation, which is the compound. If it's compounded monthly or something like that, you use the other one. Has to say continuously. R is 0.03, T is 8, plug it in, chug it out. Over here, $700. Again, it's got to say compounded continuously. So I have my amount after 7 years is equal to my principal times e raised to the 0.06 times 7. Plug it into your calculator. 700. And then use second and ln is e raised to a power. 0.06 times 7 goes up there. The calculator does the work, and I get $1,065.37. And your money is working for you. You turn that 1,000 into 1,065. This is how you want to invest if you can. Same thing here. We're working backwards here. So how much would you have deposited? Okay, so we're looking for the principal. So this one, we want to end with 1950. I'm looking for P, e raised to the 0.03 times 10. I'm going to divide by that e to the 0.03 times 10. And I'll divide by that e to the 0.03 times 10. So I'm going to take 1950 divided by second ln 0.03 times 10, and I needed to invest $1,444.60. All right, and that's kind of the quick version of natural logs. It has a base e of every time. E is just a number, people. E is just a number. It's not a letter. We've got a little homework assignment here for you to go with 6, 7, and 6, 8. We kind of do these together, okay? And so there you go.